I said yesterday, we are going to start with the examples on the spherical coordinate system, then cylindrical coordinates, then ellipsoidal coordinates. So we'll solve some of the triple integration examples using those substitutions that we have seen. So one example we have seen in the previous lecture, where we actually substituted the spherical coordinates here, and then we solved it. One more example using spherical coordinates. So example is triple integral over v z square upon x square plus y square plus z square dx dy dz, where v is the volume of sphere x square plus y square plus z square is equal to 2. Once you look at the sphere, you need to first of all think of the spherical. When you look at a circle into say, double integration, we go for polar. When we look at a sphere in three-dimensional space, then we go for spherical. So what we will put is x is equal to r cos phi, y is equal to r sin phi, then the opposite one sin theta, and z is equal to r cos of theta. With that, we also saw dx, dy, dz. This has to be replaced by, yes, anyone? What is the Jacobian here? What was the Jacobian for spherical coordinates?
R square sin theta.
R square sin theta. Dr d theta d phi. Also, this is a complete sphere. Okay, so sphere is actually in all the 8 quadrants. So this is just the one octant, and for the complete sphere, I need you to think of the values. Those are going to be for r, theta, and phi. This, this, and this. So what are the limits? For spherical coordinate system, we take the pillar which is starting from origin and it goes to the surface, whichever is there. The value of r, the pillar will start from the origin at which the value of r is 0. So what is the maximum value length of the pillar? That will be the radius of the sphere. And what is the radius of the sphere here? So r is equal to 2. है ना? The radius of the sphere is Rohit. Samyak. Aryan,
R equal to 2.
R equal to 2. Nikita, Sahil,
Sir, root 2.
yes. So
Yes, sir.
radius of the sphere is under root
Root
2. What about phi? Phi is running from 0
0 to
to
pi.
0 to
pi pi.
180 degree.
Why 180? What is phi? What is the significance of phi?
The pi by 2.
What is the significance of phi? Let's just understand what is phi first, so then we'll think of the limits later. If anyone remember, what do you mean by phi? If you understand the meaning, then it will be very easy to identify the limit. Don't understand the significance of phi, then it will be very much difficult. So this r, theta, and phi are just like your polythene. Okay, it has no meaning until you understand what is inside it. Okay, so I want you to go to the meaning. What is the significance of that phi? No one? Sumed?
Sir, the angle made by the in the XY line, XY
On
plane,
X?
I mean.
Yes. So you take the projection of whole of your space, and on xy plane you can see what angle or what how much area it is covering on the xy plane. So if you project this whole of the sphere on the ground, I mean the circle that I have drawn here, then you look at that angle with positive x-axis. So what is the angle, maximum angle the pillar will make on the xy plane?
2 pi.
2 pi. So phi is running from 0 to phi is equal to 2 pi. And the third one, theta.
0 to pi.
Okay, this is correct. So 0 to pi. So we'll substitute all these values. So we have got everything placed. I mean, what substitution we need to make, what changes are going to be there. So all of those things we have. So we'll just substitute it in this. And so what do we have? I is equal to integral 0 to under root 2. Pi is running from 0 to 2 pi. Theta is running from 0 to pi. What will be the numerator here? What is the value of z? Z is r cos theta. So this will be r square cos square theta upon x square plus y square plus z square. For a spherical coordinate system, x square plus y square plus z square becomes r square, and this dx dy dz is replaced by r square sin theta d theta d phi dr. So this 2 gets cancelled out. How can we solve the integration? All the limits are constant. Your integrand is the product of the function of r, function of theta, and function of phi. So I can simply separate this 0 to under root 2 r square dr. Then phi is running from 0 to 2 pi d phi. And in the third one, integration theta is running from 0 to pi cos square theta is 1 minus sine square theta, so that will be okay. Anyways, no problem. We can solve it directly. Cos square theta, sine theta, d theta. What is the answer? Now, further you can carry and tell me the final answer. So the final answer here is how you will solve the third integral. You just need to put cos theta as t, sine theta d theta will become dt. So you will have to integrate t square. So I'll just give the final answer as I don't have a lot of time here to solve the single integral. 8 under root 2 pi by 9. You can check the calculations and verify it later. So this is how we use the spherical coordinate system. Much more better or interesting is when you use the cylindrical coordinate system. So the question is evaluate triple integral over v under root x square plus y square dx dy dz, where v is x square plus y square equal to z square, comma z greater than 0 and z is equal to 1, comma z equal to 0. Yes, who can identify the figure? What is the first equation, at least that you can tell me?
Sir, it's the conical shaped uh,
Conical shape.
with height at z-axis, altitude in z-axis.
So it is a cone.
Yes, sir.
So it is a cone.
Sir, it's
Something.
a
So I am drawn this. Make your diagram properly. Yeah, x, y, z axis, and then I hope everyone is very much clear how it is a cone, because we have spent one complete lecture on this, understanding the figures. This is origin, this is x-axis, this is y-axis, and this is z-axis, which is the region. So with z, what is z equal to 0? Anyone? Utkarsh, where is Utkarsh? What is z equal to 0?
Sir, XY plane.
It's
XY plane.
xy plane. So z equal to 0 is xy plane and z equal to 1?
Uh, a plane parallel to XY.
Exactly. So we need to collect all the points which will have z coordinate as 1, and that is going to be z equal to 1. So I'll consider this as the point 0, 0, 1. So our plane will be parallel to this and it will cut this cone. And I need to evaluate the integration, triple integral, over the volume which is bounded by this cone and the plane z is equal to 1. So this is the kind of structure we will get and this is the volume over which we are evaluating. So I hope it is clear up to this. Now, as it is not a sphere, complete sphere, uh, we have the cylindrical system and we will use the cylindrical system here. Whenever there is going to be a cone or there will be a cylinder or there is a paraboloid, or in these cases, cylindrical coordinate system works better. Moreover, integrand, if you see, it is x square plus y square. In cylindrical coordinate system, x is equal to rho cos phi, y is equal to rho sin phi, and z is equal to z. This is the cylindrical coordinates. So you can identify x square plus y square in this case will become rho square. Okay, so even the integrand becomes simpler with this coordinates, and that's why I am choosing this. In this case, dx, dy, dz is replaced by rho, d rho, d phi, dz. Now, how to take the pillar in this case? So, in this case, the pillar is vertical. So you will have a pillar like this. It will start from the lower end of your volume and it will go up to the upper end of your volume. Okay. So this is how we choose the pillar. Now, let's talk about the limits. What are the limits for rho? What is rho? Let's recall what have we written. What do we mean by rho? In your volume, what will be the minimum value of rho and what will be the maximum value of rho? That is what you need to think. So for that, you need to understand what is rho. Anyone? If you have written this, okay. I'll go to the previous page. So what is written here on the screen? Rho is the distance from z-axis. Okay. So let's get back here. So what is the minimum distance from z-axis, which is in your region or in the volume? And what is the maximum distance that you can go far from the z-axis? Now at least can you answer this?
Rho
Atharva,
equal to 0 to
0 to
1.
0 to 1, exactly. So if you look at the upper end of your cone, in this case the last point is at distance 1 unit. Okay, so the rho is running from 0 to rho equal to 1. Then let's talk about phi. What was phi? Let's go back. Angle with positive x-axis on the xy plane. So you need to drop the complete volume on the ground and you need to see how much angle your region is going to make with positive x-axis. So it is phi is running from 0 to Yes, Rohit. 0 to Sumedh.
0 to 2 pi, sir.
0 to 2 pi. Let's talk about Z. Z is the most interesting here. What is going to be the what you need to calculate now? You need to calculate Z. Okay, what does the Z represents? The height of your pillar. Now, what do you think is going to be the height of your pillar as you move in the volume?
Z is equal to 1 that axis means that plane.
Didn't understood? Can you repeat?
So that from origin to that till that plane is there.
Only just at this point origin to 1. But what about the other points? Like on this surface, if I take the pillar,
It's a plane to
it has to be the pillar has to be from where to where? It has to be from
0 to 1.
okay. Anything else?
From the cone to 1.
Yes. Samyak, repeat it.
Cone to 1 angle.
So what will be the equation? Cone to the line or whatever you're saying.
Plus y square.
Rho is running from you're somewhat right, but you need to say it explicitly or particularly, I must say.
Sir, 0 to root x square plus y square.
The root x square plus, but we are changing those variables, right? X square, y square are not the part of my new equation. It just works like the strip. How do you use the strip? You look at the lower end of the strip, you look at the upper end of the strip. Now in this case, you will have to look at lower end of your pillar and upper end of your pillar. Yes, anyone else? Samyak was half right. Okay. So what he said was your pillar goes from this cone to this plane z equal to 1. At this point, the value of z is 1. That we know. We need to look at the lower end of your pillar. So as you move this pillar in your volume, you can see that the length of pillar is going to change. At this point, it is different. If I take a pillar here, the length of this pillar is different. So our lower end of your pillar is changing. And where is our lower end of your pillar? Lower end of your pillar is on the cone. So I need to get the value of z from the equation of cone. So what I will do is I have x square plus y square equal to z square. I will put x is equal to rho cos phi, y is equal to rho sin phi. So this will be rho square is equal to z square. So this gives me z is equal to rho. What is the lower end of your pillar? It is on the cone. From the cone, the value of z is rho 2. Z is equal to 1. I hope this is clear now. Fine. So it is very much clear. So I'll put these values in the integration and we will solve. So put I will become integration. Rho is running from 0 to 1. Phi is running from 0 to 2 pi. So Z is running from rho to 1. Under root x square plus y square is rho square. So this will become rho. And dx, dy, dz is rho, dz, d phi, d rho. Look, phi doesn't have to do anything with the z and rho, so I can separate it. Phi is running from 0 to 2 pi d phi. Let's separate this. And in the other bracket, rho is running from 0 to 1. Z is running from rho to 1. Rho square dz d rho. So this is 2 pi. In the other bracket, rho is running from 0 to 1. Integration with respect to z is going to be z. So this is rho square in bracket 1 minus rho d rho. So we can solve this integration. Now rho square minus rho cube, and the final answer becomes 2 pi in bracket rho cube by 3 minus rho raised to 4 by 4, limits from 0 to 1, and the answer is pi by. Clear?
Yes, sir.
Next example.
Sir, can you go to the previous
The
slide?
previous
Done, sir.
This is going to be more interesting here. So evaluate. Triple integral over v z square dx dy dz over volume common to x square plus y square plus z square is equal to a square, and x square plus y square is equal to ax. Yes.
Sir, are you presenting the screen right now? Because I'm not able to see the screen. It kind of went blank after the previous slide.
Is the same problem with everyone else?
No, sir, it's visible.
No, sir.
Sir, can I rejoin the
visible.
meeting?
Yes. Yes,
Can I
yes, sure, you can rejoin.
Okay, sir.
So what do we have here is x square plus y square plus z square is equal to a square. If we look at that, what is it? It is a sphere with center as origin and a radius as a.
A.
What about the second one? What is it? Look on the xy plane first of all, so that you will be able to understand. What is it on the xy plane? Adjust that ax on the left hand side, x square minus ax plus a by 2 square plus y square is equal to a by 2 square. So this becomes x minus a by 2 whole square plus y square is equal to a by 2 square. Now can you tell me what is it?
Circle.
Circle where?
Sir, on a by 2 point on the x-axis.
I am asking in 3-dimensional space, what is it?
It's a 2D object.
It is?
It's in xy plane.
Circle is in xy plane. What about 3-dimensional figure?
Sir, it is the
Okay.
cylinder along z-axis.
It is
Cylinder.
cylinder along
Z-axis.
z-axis. Exactly. So the center of this circle on xy plane is going to be a by 2 comma 0, and radius is also a by 2, as you can see. Okay. So it is a cylinder, as the z variable is absent. So you will have a figure like this, and it is increasing like this along the z axis. So this is the cylinder. So the question is, we need to find the triple integration over the volume which is bounded by this cylinder and the sphere. Okay, so I will rub this now, as this calculations have done it part. Now, as there is a cylinder, so of course what I am going to substitute, x is equal to rho cos phi, y is equal to rho sin phi, z is equal to z. We'll replace dx, dy, dz by rho, d rho, d phi, dz. What are the values for phi?
So can you repeat the question?
So I need the limits now. So first of all, we'll talk about rho. Where to where rho is going to go? So in this case, we'll have a pillar like this. First of all, let me just make this clear. So the pillar will start from the lower end of your uh, sphere to the upper end of your sphere. Okay. Moreover, we need to think of phi. So on this ground, I'll make a strip. Okay. So this strip is going to give me the value for theta as well as phi. Okay. So what I'm going to do here, so first of all, I'll think of phi. What is the value for phi? Phi is going from this end of your circle to upper end, right, on the xy plane. So phi is going to be running from minus pi by 2 to plus pi by 2. Yes, am I right? Phi is going from minus pi by 2 to plus pi by 2. What about rho? Rho क्या देता है? It is the distance from the z-axis to your region. So ये जो pillar है, it will move along this circle which is drawn inside this sphere. So it will start from the origin. So rho is running from 0 to what is the end of your strip? That is this edge of this circle. So if I put x is equal to rho cos phi and rho sin phi in this, what we'll get? Rho square is equal to a, the value of x is rho cos phi. So this 2 gets cancelled out. Rho is equal to a cos phi. And the last and not the least is the value of z. What is the height of your pillar in this case? So z is going from the lower end of your sphere to the upper end of your sphere. So if you look at the lower end of your sphere, that will be z is equal to under root of a square minus rho square minus 2. Z is equal to under root a square minus rho square. So this is the complete thing that we have now. Let's put all the values. If anyone have problem up to this, please ask. Take 2 minutes, try to identify what I have done there. Try to understand it properly. And if still the problem persists, then please ask. 0 to a cos phi. Third one, z is equal to minus root a square minus rho square to plus root a square minus rho square. Z square is z square as it is. And then we have rho dz d rho d phi. So I'll consider that there is no problem till this.
So can you explain the limit for z again?
Can you tell me pillar, what will be the lower end of your pillar? Anyone?
So the sphere.
It will be the
maximum sphere, sir.
here lower so lower end of the sphere and upper end of your sphere, that is going to be the limit there, and in that case what we will have is just a minute, where the equation x square plus y square plus z square equal to uh, 16, I will say. Then square So I hope the screen is visible now. So the diagram is going to be like this. Okay, so you have a sphere and then it is cut down by this cylinder. So when the sphere is cut down by the cylinder, so I'll zoom in a bit. So whatever the intersection part you have, so you can see that the cylinder here, there is a circle on XY plane is going upward, downward. So the intersection of the cylinder and the sphere will have this region. And if you take a pillar over here, then it will start from the upper end of your sphere to lower end of your sphere. That's what I wanted to convey from the diagram. And at the low, what is the equation of the sphere? Equation of sphere is this. Now in this equation, I'm substituting these values. X is equal to rho cos phi, y is equal to rho sin phi, and z equal to z, in order to get the values of z in terms of rho. So if you simplify this, you have z square is equal to a square minus x square plus y square. What is x square plus y square? If you substitute this, it is rho square. So
Rho
z
cos
square is equal to a square minus rho square.
Yes, sir. Got
Z
it.
is under root a square minus rho square plus minus. That's why. Fine, we'll go ahead. Okay, what I was doing was, I'll rub this now, as the limits are very much clear. Now the only task is to solve it. Solving is very easy. Again, it is just 12 standard mathematics. So minus pi by 2 to plus pi by 2, 0 to a cos phi. So we have the integration with respect to z. So z square is going to be z cube, limits from under root minus a square minus rho square to plus under root a square minus rho square d rho d phi. This is minus pi by 2 to plus pi by 2.
Sir, upon 3 also, right?
Yes, exactly. So 1 by 3 I'll take outside. So a cos phi, we have rho in bracket, upper limit. So a square minus rho square raised to 3 by 2 minus a square minus rho square under root का cube करोगे, still it will become minus, and this will make it plus a square minus rho square raised to 3 by 2 d rho d phi. So that will be 2 by 3 integration minus pi by 2 to plus pi by 2, 0 to a cos phi. We have a square minus rho square raised to 3 by 2 into rho d phi. How can we solve this integration now? So a square minus rho square can be considered as t, and 2 times this, I'll make it 1 here, and I'll make this 2 rho d rho. So if I'm considering this term as t, this term becomes dt. So what we are actually integrating is t raised to 3 by 2. So what is the integration of t raised to 3 by 2? T raised to 5 by 2 upon 5 by 2. So 1 by 3 integration minus 5 by 2 to plus 5 by 2. The integration is a square minus rho square raised to 5 by 2 upon 5 by 2, limits from 0 to a cos phi d phi. So this becomes 1 by 3 into 2 by 5, so that is minus 2 by 15. Integration minus pi by 2 to plus pi by 2. When you put the upper limit, you will have something that is a square minus a square cos square phi total raised to 5 by 2. When you put the lower limit, you will have actually a raised to 5. Is it correct? Minus a raised to 5 and d phi. So if you simplify this, minus 2 by 15,
Sir, it has to be 4, I guess. 4
which,
upon 15. Because there
why?
is a 2 also there.
Where is 2?
Sir, there is 2.
No, that was adjusted in the derivative, na?
Yes, yes, sir.
When you put the upper limit here, I think I may be wrong only at this place. So when we put upper limit a cos phi, so a square minus a square cos square phi raised to 5 by 2. Fine, it is correct. Minus when you put 0, you will have a square raised to 5 by 2. So a raised to 5. Okay, no problem. So minus pi by 2 to plus pi by 2. You take a square common. So a raised to 5 totally outside into 1 minus cos square phi, that will become sine square phi. So sine raised to 5 pi minus a raised to 5 d phi. Right? Now, how to solve this? What is sine theta? What is sine theta?
So we can break it into two parts.
How?
Sir, A is constant, no? So we can take a raised to 5 as different integration and a raised to power 5 into sine 5 phi as different integration.
Okay. Integration, just tell me whether you understand this. 1 minus sine raised to 5 phi d phi.
Yes, sir.
This is 2 times, so this will become 4. Minus pi by 2 to plus pi by 2 hai. So a raised to 5 I am taking common, and now we
Sir, it
can.
should be like uh, sine power 5, 5 minus 1. Na?
There is
Why?
minus sign outside also, na?
Okay, sir.
Na? So I'm trying to make this plus, and I'm changing the sign. Okay, so that is 4 by 15 a raised to 5. So you have integration of 1, which is going to be pi, so that is pi by 2, minus what is the integration of sine raised to 5 by our reduction formula 5, 4, 3, 2, and 1. What about 1? As it is. So the answer is 4 a raised to 5 divided by 15 in bracket 5 by 2 minus 8 by 15. This is the final answer. Fine. We have actually ended with the triple integration. Just one last theorem is remaining that will hardly require 15 minutes. So I'll do it in next lecture. And by then you can just try this in 2 minutes. Triple integral over V under root 1 minus x square upon e square minus y square upon b square minus z square upon c square dx dy dz throughout the ellipsoid. X square upon e square plus y square upon b square plus z square upon c square equal to 1. You have 2 minutes. Please tell me fast so that we can end the lecture quickly. How do we proceed here?
Sir, it should be 0 now.
What? What should be 0?
Like if we put the value in that equation.
You cannot put that value in the integration. Na? You are integrating over that volume.
Sir, it is, I think, egg shape.
Yes, egg shape. You are exactly right. So how do we go ahead now? What is the substitution for this?
X equal to 0 to a.
No. In the previous lectures, we also have seen this elliptical coordinates. So whenever you are going to have ellipse, we need to go for this coordinate. These are the coordinates which are just similar to the spherical. Just you are adding the factor of x-axis, y-axis, and z-axis. I mean major axis and minimum axis. That we can speak in that terms actually. So ABC are those factors corresponding to x, y, z axis for an ellipse. So we'll put x is equal to a r cos phi, y is equal to b r sin phi, sin theta, z is equal to c r cos theta. So dx, dy, dz will be replaced by ABC r square sin theta, dr, d theta, d phi. So r here is going to be from 0 to 1. What about phi? On the xy plane, if you see, it is making the complete angle up to 2 pi. What about theta? It is complete ellipse. So it is also going to be from 0 to pi. Let's substitute all these values in the integration. So we'll have 0 to 1, 0 to 2 pi, 0 to pi, under root 1 minus r square, dx dy dz is abc r square sin theta. What has to be the order? D theta, d phi, and dr. So limits are constant. Integrand is the product of the functions of r, theta, and phi. So I can simply separate it. ABC being constant can come outside. 0 to 1 under root 1 minus r square r square dr. The first integration that you need to solve. The second is 0 to 2 pi d phi. And the third one, 0 to pi sine theta dt. Yeah. You can simply solve this. These are simple now. In the integration of root 1 minus r square, you just need to put r is equal to cos or sine. You will be able to solve it. And other two integrations are very much easy. So I'll directly give the answer. It is pi square abc divided by 4. So this is all about triple integration, multiple integrations actually. 95% of multiple integrals is over. Just one last theorem which will actually simplify a lot of integrations. Just in 2 to 3 steps you can actually give the answer for multiple integrals, and the name of the theorem is Dirichlet's theorem. So in tomorrow's lecture we'll see Dirichlet's theorem and two applications of multiple integrals, and we'll end our largest module. So maybe in coming 1.5 week we will also be done with our syllabus.
How many chapters